Hi everybody, I'm Charanpreet and I will be conversing with you on this fascinating phenomenon called the digital revolution, how it is poised to impact the way we live and work, and the skills required to thrive in the digital world. We will also explore the world of analytics and data science and understand why a career in this field is so widely talked about and sought after. I would like to make this session interactive, so please ask questions whenever you want to. You'll have to type the questions, and I'll be able to see your questions on the screen. As and when I see a question, I will stop and answer the question and then take the presentation forward. The way this presentation is structured is as follows. I will start with a couple of examples that demonstrate the use of technology and data in business. And then after that, I will take you through what this digital world really means, what are the skills required, and finally, what kind of careers are available in the fields of analysis and analytics and data science. Before we start, let us agree with the following three things. The first thing is that the world around us is changing at an unbelievable pace. This makes life interesting, but also throws up several challenges. Two, most of these changes are driven by progressively innovative use of technology. So technology is at the heart of this entire revolution. And three, these changes are impacting the way we communicate, the way we consume, the way we learn, the way we work, and basically the way we live. For example, social media has impacted the way we communicate. Swiggy has impacted the way we consume. Online learning platforms that offer self-paced, personalized training have changed the way. And when we have to work with robots on the shop floor, it has really changed the way we work. Now let us look at a couple of examples to see how businesses use digital technologies to stay ahead of the competition. My first example or story is the story of Netflix, which offers subscription-based online streaming of a library of films and television programs, including in-house productions. Netflix has built this business by developing a very sharp understanding of its customer preferences and providing highly personalized content. If you look at this graph, by 2018, Netflix already had 139 million subscribers, and I'm sure many of us in this discussion are subscribers of Netflix, and this number is growing every day. So the question is, how does Netflix make money? That is, what is their revenue model? Well, it's pretty simple. Netflix streams content to its subscribers, and subscribers pay monthly or annual fee to Netflix, which means that to remain competitive and profitable, Netflix has to attract customers, then it has to convert these customers into subscribers, and finally it has to retain these customers over a long period of time. Netflix uses analytics at every stage to ensure that they select and create the right content to keep their customers happy. Now, as the slide shows, Netflix has only 90 seconds to convince the user that it has something for them to watch. Otherwise, the user will abandon the service and move on to something else and will lose this prospective customer forever. So given this short period of time, what does Netflix do? Fortunately, Netflix has access to a lot of data. Now let us look at the kind of data Netflix has access to. To start with, Netflix keeps a close watch on what are you watching. And I will share with you in a couple of slides how sharp they can get on this. Second, Netflix also tracks the devices or device on which you watch the content that you watch. This helps them to create the right technologies to be available on the devices that they need to be available on. Netflix also tracks the time of the day and the day of the week that we watch, and they have some very interesting conclusions on what kind of people watch what kind of content, what day and what days of the week. In addition, Netflix also looks at customer profiles, they look at the customer gender, they look at the customer location, they also look at what the customer does while the customer is watching content. That means, how many times did the customer press pause? What was the situation of the screen at which the customer pressed pause? When did the customer fast forward? How many people watched an entire series without abandoning it? What was the average rating of a product? And how many people gave a thumbs up to the product, etc., etc. Now, this is a whole lot of data, and tracking and analyzing this data gives us what are called actionable insights. What actionable insight means is I'm getting insights from this data. Not only that, I can take positive action on this data to improve the service that I provide to my customers. So now let's look at, as I was saying, the sharpness levels Netflix has gone to. The service has created 76,897 unique ways to describe types of movies. That is really fascinating, which means that if they have to personalize and recommend a film to you, they will choose one out of more than 76,000 types of films to recommend to you. So it's not a surprise then that 80% of all content that is watched on Netflix is the result of recommendations that Netflix makes to its customers. Now, if you look at it, it's very interesting. If I watch something recommended by Netflix, it increases my loyalty to Netflix because Netflix makes it easier for me to watch content because I don't have to really search for it. And as I become more and more loyal to Netflix, I spend more and more time with Netflix. Netflix actually makes more money. So that is the beauty of this technique called machine learning that Netflix uses to sharpen its recommendation to its users. Moving forward, let us see something more that which will really, I mean, it actually blew my mind, and maybe it will blow yours as well. That once Netflix has a near complete picture of the viewing habits of its subscribers and knows what subscribers watch and when they turn off and what path they most often take between titles, it has now figured out that most of the people watch a film after watching their favorite shows. Not only that, they have also figured out that if they know their customer and if they know what kind of show the customer has watched, they also know what kind of film the customer is most likely to see after watching the show. Which is why they have actually created associations between shows and films and a kind of relationship that this film should follow this show given the type of customer that has watched this show. This again enables Netflix to get more time out of their customers and make them watch more content. Because, as I said before, if they are addicted to Netflix, it is very likely that they're not going to leave it. And finally, all this analysis and all the information that they get about customers, it enables them to assess what kind of titles are that are likely to provide the biggest viewership per dollar spent. Now, let's look at this dollar spent concept a little. Netflix has to pay its suppliers or its providers for the content that they buy. For example, if they buy a film or a TV show, they have to pay for that. And sometimes these can be very, very high. So to be able to make money, they want a larger viewership to be able to actually, kind of get past this expense that they have. So if I know my customer very well, I can go out into the market and actually acquire the right content for higher viewership. And the result of that is that Netflix has in the past couple of years acquired more than double the content that the top 5 competitors together have acquired from the market. So that kind of keeps Netflix far, far ahead of its competition. And the reason I actually, kind of related this story at the start of this seminar or webinar is that look at the power of technology and look at the power of data and the power of making good use of the data. You actually build a business and grow faster than competition, which has been there for decades. My example is even more interesting in some sense because I'm going to talk about a coffee house. Now, the question is Starbucks a coffee house or a technology company? Starbucks calls itself, the third place between your work and home. The home is your first place, your work is your second place. But when you walk back from work to home, you must stop by at a Starbucks coffee shop, and that's your third place. So, what has Starbucks done? Starbucks has to grow, and it is now in 65 countries and has more than 29,000 stores. Now, to keep growing, Starbucks has to open new stores. And to open a profitable store, they have to have a very good handle on the location in which they want to open that store. So, what they have developed is a very interesting system called Atlas, which is an in house geographic information system, which kind of guides them into uh, getting the right location for their stores. So what does this system do? It looks at, and you guessed right, a bunch of data. It looks at the kind of traffic that location has. It looks at the demographics of the people that are close to that location, including the income levels that the people have. It looks at the density of office buildings in a particular location. It also looks at traffic lights because they believe that you don't have parking space close to traffic lights. So a Starbucks store very close to traffic lights may not do as well as a Starbucks store which is slightly away from traffic lights. They also look at new buildings coming up in a location because finally those buildings are going to be filled up with people and those people are going to come and drink coffee. So they have developed complex algorithm which takes inputs of all these data and then tells them what are the right locations for their stores. So this is what is called a heat map. And this is a heat map of the Manhattan Island. And the dots or the things that you see over there are Starbucks coffee stores. And if you look at the color combination, the deep yellow is where the concentration is the highest, and then moving down the color gradient where you have high to medium to low concentration of stores. But this is not done by guessing or intuition or past experience. This decision is driven by hard data and hard analysis of data. The other thing that Starbucks is very good at is driving customer loyalty. And what they do with that is that they look at what each of their customers drinks and how much the customer spends on the stores. They also look at things like weather conditions and spending patterns, income levels of the neighborhood, and that's how they create new products, they promote existing products, and personalize their promotions to their customers. This results in huge levels of loyalty, and if you have loyal customers, you make money. So the reason I gave you these two examples is to show that it doesn't depend what business you are in. Today, it's only your imagination that decides how much technology you will use and how much of data you will use to make that business profitable. Moving forward, we come back to our main theme, the pace of change happening in the world around us. And it is now widely accepted that in what we call the most, transformative times that human evolution has ever seen. And there's a very interesting 2x2 matrix that describes this, which says that the speed of change as well as the extent of change are incredibly high. And when we have both the extent of change or the magnitude of change and the pace of change that high, we label it a revolution. So, which is why experts say that today we are living in an age of what is called the digital revolution. So, what happens in a revolution? Things that were traditional get disrupted by things which are new. And let us look at a few examples of this digital disruption. I'm only going to pick a couple of these. Uber, which is now the world's biggest taxi fleet, owns no cars, uses technology and data to manage a massive fleet of cars owned by its partners. If you compare Uber to our traditional yellow and black cabs, Uber is not an incremental improvement over the traditional taxi service. It is a completely new way of providing the service, and it has disrupted the existing service model. Similarly, if you look at Airbnb, it's the largest hospitality brand in the world but owns no real estate. It does not own a single building. This is again an example of disrupting the way a hotel business is run and using technology to move ahead of competition. I think by now we have established that the traditional is threatened by the digital way of doing things. We can also suspect that the knowledge and skill sets that are required in the traditional businesses may not really work in this new world. So to understand digital in a little more detail, let's look at the four components of digital. Social, which is social media, which connects all of us. Mobile, which is the device that all of us use to experience digital. Cloud, where all the huge computing power that is required to support digital happens. And analytics, the interesting and intelligent things we do with all the data that digital creates. However, if you want to simplify digital, then at its simplest level, digital transformation actually means transforming an organization's business and culture by leveraging technology and data. So we are back to these two themes that will be there throughout the seminar today, and the two themes are technology and data. Let's now look at the skills. As we said, skills that were there in the traditional world may not be applicable in the modern world, or the digital world may require to have different skills. While basic skills like teamwork and communication will always be relevant, let us look at a few specially important areas one must strive to strengthen to be successful in this digital world. My first pick in this list is the skill of learning how to learn. Sounds a little weird, but once we accept that technologies and business will continue to change at a frantic pace, we have to keep learning at the same speed to simply keep up. It's like running on a treadmill to remain at the same place and not fall off. You cannot divide chunks of time separately for learning and for working all your life. You have to learn on the fly, a new technology, a new way of doing things as you work. For this, you need to train yourself to be a very smart learner. There are techniques that enhance your ability to learn, and you have to be aware of them and to practice them. For example, our faculty team at Praxis experienced that over the last few years. We pioneered the teaching of analytics in the country in 2011, and since then, this area has seen tremendous changes. Our team of professors have had to update themselves continually and learn to learn quickly, else they wouldn't be in a position to teach what we today teach with the knowledge that they had 7, 8 years back. The second skill that I would like to pick here is the skill of critical thinking, which essentially means to think logically and creatively about issues and question everything till we are satisfied with the answers. Critical thinking is essential to cope with the complexities of the modern business. It requires sharp analytical skills and the ability to innovate, to understand, define, and solve problems. The good news again is that we can train the mind to think critically, and my suggestion to you is that you must do that. The next two skills are more tangible and hence easier to understand. The first, technology skills, and the second, data skills. As has been our theme throughout the session, tech and data are the drivers of the digital revolution. Every manager should be tech and data literate because these two entities impact every aspect of the manager's business. So, irrespective of the background you come from, it is important to strengthen yourself in these two areas. For example, if you are a marketing person, you need to know digital marketing and Google Analytics. And if you are a finance person, you have to be aware of blockchain and cryptocurrency. And finally, as more and more of our processes become digital and more machines get connected to the internet, the amount of that data that is generated explodes. This creates tremendous opportunities for those people who have the ability to understand and work with data to get useful information for the business. This is what we will talk about now, careers in data science and analytics. So what we will do here is we will attempt to answer three questions. The first question is, what is big data? Everybody talks about it, but what really is big data? The second question is, what is data science? Again, there are several labels here: data science, artificial intelligence, machine learning, analytics, business intelligence. So let's try and demystify these. And the third question, which probably is the most interesting for all of you, is why is data science considered to be the best job in the 21st century? I'm not saying that. The Harvard Business Review said that, and several years back, and Forbes said that last year. So obviously there is some truth to this. Start with big data. So when we say big, let's find out how big is the data. So this is, this is a fascinating chart because it says that we have now gone beyond the decimal system, which means that you look at the powers to the 10. We are today pretty much in the age of gigabytes and terabytes when we look at our laptops. But once we move outside that world, we go to petabytes and exabytes and zettabytes and yottabytes and brontobytes and finally geobytes, which is 10 to the power 30. And so if you want to get a handle of that, let's look at something to the left of your screen. Let me see if I can point this out. What is a brontobyte? You guys must have heard of what is called the IoT, Internet of Things, when all machines and everything, even our clothes, are going to get connected to the internet. The massive amounts of data that these machines will generate in the future will reach brontobyte levels, which is 10 to the power 27 bytes, which is like a kind of data that is difficult to even imagine. To put things in perspective, we have generated more data in the last 2 years than we have generated since the start of civilization. To 2017, that means, and from the start of civilization to 2017, we've generated data. We've generated more data than that in just the last 2 years. The other thing about big data is it's the kind of data that we cannot really handle with existing database management systems. So the technology that is required to store the data, the technology that is required to handle the data is different from these that we've been so far taught in our schools and colleges. So that makes this big data interesting as well as challenging. The other thing about this data, the variety of this data, is another thing that is interesting. Previously, most of the data that we handled was machine data, okay, which now gives us only about 10% of the information. Most of the information comes from two other sources: machine data, which we already talked about, and human data, which is the kind of data that we get on our social media, including Facebook, Instagram, Twitter, and people talking to people in the digital space. These are the two kinds of data. Machine data is what is called semi-structured data. Human data is what is called unstructured data, and business data is what is called structured data. So when we start analyzing data, we have to analyze machine, human, as well as business data. To give you an idea of the speed at which data is being generated, this is a chart of what happens in 1 minute on the internet in 2018. So you had 973 Facebook logins in a minute, 3.7 million searches in a minute, 18 million text messages on WhatsApp in a minute, and or 38 million text messages on WhatsApp in a minute, and so on and so forth. Now remember, for a data scientist, every search is data, every message is data, every like on Facebook is data, every upload is data, every share is data. So if you look at the total volume of data that is available for analysis, it seriously boggles your mind. So this is what is big data, and the reason it's interesting is that if we can analyze it and get insights out of it, it can help governments and businesses and people. Another example of machine data, just to tell you, if we look at the sensor data collected from US commercial jet engines during 1 year, okay, it is 1,000 million terabytes of data just generated by commercial jet engines in the sky in 1 year. And the way to calculate it is that every engine generates 20 terabytes of power. An average aircraft, Boeing 737, has two engines. The average duration of a US domestic flight is 2.5 hours, and the number of commercial flights in a day is about 28,500, and there are 365 days in a year. So if you calculate all of that, you actually generate 1,000 million terabytes of data just from jet engines in the US airspace. Now look at all the machines across the globe, and you will get a kind of feel of the kind of data that we generate. Insisting on covering this is I'm just trying to show that what kind of opportunities lie for people who have the ability to understand this data. It's complex, so everybody's not going to be able to do it. It requires training, so everybody's not going to seek that training. So if you have the ability to do it, and if you get trained to do it, you have a huge career ahead of you. Our second question, what is data science? Right? So I just picked one of the definitions which I thought was simple and understandable. It's a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured. So let me explain two or three quick things here. The first thing, it is multidisciplinary, which means it requires skills and knowledge from different disciplines, and we will discuss that in a minute. So that's one key. The second thing is it uses scientific methods. So data is a science. Data science is a science. It uses scientific methods and processes. It uses what are called algorithms, which are kind of models that people build, which work in different situations, right? A model or an algorithm is something that you build on the basis of learning situations, and then those algorithms are applicable to new situations. So it kind of becomes like a template that we can use and reuse, and they become very useful because of that. Why do we do that? We want to extract knowledge and insights from data. So data is raw, and then when we extract the data that we want, it's called information, and then we combine information with our knowledge and our context of the business, it becomes knowledge. And it gives us insights. It tells us what is actually happening in our business, or what is actually happening in our country if we are a government agency. And that knowledge and insight helps us make better decisions, helps us become more effective in providing the right service to a customer, helps us in, let's say, providing the right information to the farmer working in a remote field, helps us to give the right information, let's say, to a doctor working in a remote area with a patient in a critical condition, and so on and so forth. I'm now trying to look at how this whole thing has evolved. Statistics, which is one of the disciplines of data science, has been there for a couple of 100 years now. So what humankind started with was Let me look at the kind of data I have and understand what happened in the past, because that can give me some interesting things that I can improve upon. So if I lost market share in a particular business, why did I? Then we come to why did it happen? What happened? I lost some market share. Why did it happen? Okay, maybe I made these mistakes because that's what the data tells me. Where does analytics and data science become really important and really different is today, with the kind of data and the kind of compute power I have, I can actually predict what is likely to happen if I continue to do the things that I'm doing. And then once I know what is likely to happen, can I use more intelligence to also figure out what should I do now that I know what is likely to happen? What are the things that I should change in my business to make what is likely to happen more favorable to me than it looks like today, right? So if I know that if I continue the lifestyle that I'm continuing, I might get diabetes in the next 6 months. What are the lifestyle changes that I need to adopt to prevent getting diabetes in the next 6 months, right? So that's an example that I hope all of us can understand, especially people at my age can probably understand it better than people at your age. Yeah, but this is the power, real power of data science and analytics, is that we can predict, and with the power of prediction, we can also prescribe to some extent what decisions would be most useful in improving my business or my services, right? So from hindsight to insight to foresight. Moving forward, let's look at what you guys have been probably waiting for all this while. What kind of career opportunities does this domain provide? So there's a lot of data on this across various, areas in Google and various sites. So I have kind of picked what I think are the three main areas. There are several sub areas here. Start with data analysts, starting from right to left in that sense. So data analysts are people who are good at analyzing data. They are also good at understanding business. So they're usually people who understand a particular domain of business and are good at analyzing data, understanding and analyzing data of that business, right? And they're also good at communicating what they have understood. They are also good at, let's say, you know creating graphs and charts that help managers understand what's happening in their business and take decisions. A data scientist, on the other hand, moving to the left of the screen, and this is what we call the rock star of this entire kind of domain, is somebody who has knowledge of the business, understands technology at a reasonably deep level, and understands mathematics and statistics as well. So it combines knowledge of technology, knowledge of business, knowledge of maths and statistics to understand business problems, put them in the context of the business in which these problems occur, understand what is the kind of data they must seek, and prepare that data for analysis, analyze that data, and get insights, actionable insights from it, communicate those insights, and help companies take better decisions. That's what a data scientist does. Now, as I said, technology is a very important part of this whole phenomenon, because the amount of data we have and the amount of things we do with this data, we need to have a very strong technology backbone running behind, an engine running behind. And that engine is managed by what are called data engineers. So data engineers are basically people who understand IT architectures. They understand processes that are required to store these large volumes of data and to help extract the kind of data that data scientists or data analysts want, and basically administrate the entire database that exists in that company or that organization. So these are the three principal roles and career opportunities that are available to people. And let's move forward and see at least a couple of them in some details. For example, let's look at a data scientist. So one is, data scientist must have programming skills, must be able to understand and write programs and interpret results. A data scientist must be strong in numbers, should have mathematics and statistics knowledge, and must also understand the business in which he or she applies his or her science. So difficult to find someone who's equally good and at all three. So usually when you come across a data scientist, he or she will have one very strong suit, maybe is very strong at maths and stats, has now adopted and learned programming, and is also learning the business that he or she is in. Or somebody who comes from a technology background, learns the math behind the algorithms, and then works in a business and gets the domain knowledge. So you have to start with one very strong kind of arm weapon that you have, and then kind of start learn the other two to become a data scientist. So just moving forward with this, if you understand mathematics and knowledge and statistics, and you know your business, you can get into operations research. If you are a programming, a good coder, and you also understand maths and stats, you can get into machine learning, which is one of the principal techniques that data scientists use. And if you are good at programming and or computers, and you understand business domain, you can get into things like relational database management and ERP, business intelligence, and things like that. However, if you know all three, you can get into what is called data science. I think this will give you, an idea of why data science is such an aspirational thing today. Because if you can get into a data science role, you are already a star in your organization. You belong to, one of these really, glamorous teams, and you command respect, and you obviously make a lot of money, right? So everybody wants to become a data scientist, and it's difficult to do that, right? Okay, so what do data scientists really do? So one thing is, they ask questions. All scientists are very good at asking questions. So your first assumption is, I don't know what's happening. I don't know what the problem really is. So I'll ask questions. What is what? I do not know. I would like to know. This shows that you have an open mind, and you are willing to listen to people and look at data, and then form an opinion of what is actually going on. Once you get the data, you play with the data, you look at it in different ways, you do different operations on data, and you start discovering things that you did not know. Next step, you create models and algorithms. You discover what are called patterns in data. For example, people who read this book also read these 5 books, or people who watched this film in Netflix also watched these other 3 films on Netflix. These recommendations come from models that these companies create, which are, as I said, reusable. And finally, you can create data products that deliver actionable insights. We've already seen a couple of these when we discussed Starbucks. For example, they have something called Atlas, which is a data product because it's a geographical information system, which, when it gets certain inputs, can come out with an answer which is useful and profitable. So it's a data product. And finally, a data scientist should be skillful at telling relevant business stories from data, which means the data scientist should be able to explain to you, what was the problem, what is the kind of data that was used, what was done to the data, what are the outcomes, and what it means to the business, right? Okay, I think this is a good time for me to pause a bit, and just I want some comments on, is this making sense? Do you have any questions at this stage, or do you just want me to move forward? Yeah, anybody? Yeah. Yeah, so mathematics will be of which level? Because I have done, sorry, I have done, yeah, studied mathematics till grade 12th. Yeah, so that's Harsh asking that question. Yeah, okay, so if you've done science math till class 12, I think you should be pretty okay. Of course, it would have been better if you had done math in your graduation as well. Okay, but yeah, if you've done math till class 12 and you enjoy math, my take on this is it's not about whether you're good at math or not, or you're brilliant at math or not, but if you enjoy numbers, you understand math, and you're willing to put in the hard hours, I think that should be okay. Yeah. Uh, so Yeah, so what does the data science job involve? So I have described a little bit of this already. The screen that you have in front of you does describe this in some detail, but I'm going to do a little more of that. So I think I will just hold that question now, or maybe I'll answer it right away. So what does a data scientist do? I'll tell you. I think a data scientist solves problems. Okay, and a data scientist must have a problem solving attitude. How does a data scientist solve problems? He or she does that by converting a business problem into what is called a data problem, and then uh, seeing that, okay, fine, if this is the problem, this is the kind of data I need to look at, and once I have this data, what can I do with this data? What are the techniques I can use with this data to get some this data? Because remember, this is not data which is 100 rows and 3 columns. This is data which has a million rows and 5,000 columns. So looking at the data, you can't really understand anything. So you will have to use technology to try and see, can I discover some patterns in this data, right? For example, uh, if I talk about somebody wants to increase their sales at a restaurant, and if I look at the last 2 years of data and what customers have ordered and how they have come, can I find out that what are the dishes that work better in which weather conditions? Or, 40% of the people had this particular drink when they had this particular meal. So can I give let's say a promotion on that meal and that particular drink, so that the other 60% of the people who had that meal will also have that drink, and that will increase my revenue, right? So, right. Okay. Yeah. Difference between OYO rooms and Airbnb business model, and why both are very different but doing the same thing on the ground level. So I don't really know details about their business models, but I think that I mean, at a high level, they actually do the same thing, right? Both of them hire out real estate and then use technology to acquire and provide services to their customers. Okay. The other one difference, I think one difference that you may look at is that OYO typically targets existing hotels, right, and converts them into OYO hotels, whereas Airbnb more targets homestays. So basically, it acquires people who who are willing to hire out one or two rooms in their house, or they have, let's say, an extra property that they're not using now. So in some sense, I have stayed in Airbnb properties, but I've not stayed in the OYO property. My experience with an Airbnb, first of all, my digital experience has been brilliant. So they have a very good navigation system and review system. And since we are literally going into somebody's house and staying there, there is a very personal experience that you get, right? The other differences could be how careful are they about quality considerations, OYO and Airbnb, because the quality that I got in the Airbnb service was pretty good, right? Okay. Uh, yeah, is programming going to be an intense one? So my answer to that is that will need to know programming. Okay. Uh, but yeah, so this is who's asking this question. Let me see. Akash. Okay, Akash is asking the question. Yeah. So let's say it is not as intense as the programming that a regular developer is required to do in an IT setting. You will have to learn, let's say, Python, which is an easier program to learn, a programming language to learn than the earlier languages. Uh, you will have to, when you are working out models and you are writing out models, extracting data, cleaning data, you will have to do some programming. So I would say that a good some amount of your time will surely go into programming, but you will not be a programmer or a developer. You will be a problem solver who will be writing some programs to enable to happen. That's what you know. I hope that that answers your question. Yeah. So Jaydev wants to find out whether he can switch from sales to become a data analyst. I think from sales to data analyst does not seem to be a very tough task. From sales to data scientist might be a little more difficult. However, um I mean, it also depends on your background, your 11, 12 background and your graduation background. If you went into sales after, let's say, doing an engineering course, or doing a BSc or something, or economics, uh, or did you get into sales after doing something, something, a commercial graduation? So that will also play a role here if you want to get into data science. But data analysis, as I said, good with numbers and you like numbers, that should not be a big problem. Okay, lots of questions. Uh, Saurabh, to answer your question, whether you can you learn programming on the way as you as or learn coding on the way. So the trouble is, you first have to get a job as a data scientist, and most people would be a little unwilling to give you a role unless you can demonstrate that you know some programming, right? So and also this is something that I always tell all our students also, is that it is not just about getting into a data science role. It is also about enjoying it and doing good at it. And it is always easier to enjoy something when you are very knowledgeable and very skilled at it. So you will enjoy cricket more, isn't it? So if you want to move into data science, I think it's a good idea to actually get a very strong foundation in the kind of technology that a data scientist requires, which is namely, as I said, surely Python, right? So it's good, and also the technique. So it's a good idea to spend time, understand these things really well, so that when you get onto a job, it's easier for you to perform better, right? So I can't take all questions. I'm just picking a few here. Yeah. Uh, Looking at the current scenario, this is a question from Rohit. Looking at the current scenario, why European countries are not interested in big data and stuff, but Indians are way more interested, even though we don't have the resources to train our manpower for the same. Looking at the trend, how do you see the scope in India and European countries? Rohit, I am not sure where you have this information. uh, Keen on data science. I mean, um, uh, we get a lot of interest in from European companies as well, for training people, although we haven't done that, and also consulting assignments. I think Europe may not be as much as the US, but I don't think it's fair to say that Europe is not embracing uh, data science. India, there are two interesting aspects when you come to India and data science. One is we are considered to be technologically and number wise very smart people across the globe, right? So there is a lot of interest in data scientists from India. So a lot of global companies are creating hubs creating India as the hub of their data science and analytics work. So that creates a lot of career and business opportunities in India. The second is Indian companies themselves. So, I mean, we can see from our experience with Praxis, every year the demand for data scientists is increasing in two ways. We are getting more and more companies coming to campus for placements, and the companies that repeat and come every year are recruiting more and more. Because Indian companies, especially in sectors like BFSI and retail, and now increasingly in other sectors as well, are creating pretty large analytics teams and data science teams because they realize that that's the only way they can be competitive. And thirdly, there are so many companies that have been created in India, we call them service providers, who have created businesses around providing data science and analytics services to global clients. So that is a area where you have massive career opportunities. So India, I mean, a recent report said that India, 70% of all data science work or analytics work in the globe happens in India. I'm not so sure how accurate that report is, but I have read that somewhere. Yeah. Okay, so let's move forward a little. I think I'm very happy with the questions, and we will move forward, and maybe after another 5 minutes or 10 minutes we'll have another pause. Yeah. Okay. Right. So let's look at applications of data science. So I think there was a question somewhere that who employs data science people. Every company will employ, because all companies require people who can understand and work on data. So if you look at financial services, retail, healthcare, telecom, manufacturing, I mean, we have only 5 sectors here because the slide cannot accommodate anymore. I mean, government is a very large data science. They use that for governance, for fighting terrorism, for better security, agriculture, and so on and so forth. And if you want to look at within each of these verticals, there are several areas. For example, let's look at, for example, within telecom, churn management is a big area because it's so easy to switch services. And if you switch, if I log out of your service and join another one, then I no longer give revenue to you. So can I predict which of my subscribers are likely to churn in the next 3 weeks? And if I can predict that, can I do something with them to prevent them from churning out? Churning out means leaving the service and joining another, right? Similarly, if I look at retail, if I can forecast demand of a particular product in my retail store, then I can manage my inventory better, so that I only order the precise number of items of a particular product, because I know that in the next 2 days this is the demand for this product. The more accurate my demand, the lower my costs of servicing my customers, because I will not lock up more money in my inventory. Yeah. So in financial services, there are a host of things that I can do. I mean, I can do portfolio management. I can beat the Sensex every time if I have an algorithm ready to predict stock prices and so on and so forth. Yeah. And I just thought that since everybody goes and shops, let us just look at data science in retail in little more detail, maybe a minute or so. Also to give you an idea that how deep this science has gone. So just if you look at retail, there are 4 major areas: customer analytics, marketing analytics, merchandising and planning, demand creation, and supply chain. Some of you must have realized that if you don't know retail well, these things don't make a lot of sense to you. Which brings us to our point that you can't be a successful data scientist unless you understand the domain in which you work. So let's look at, for example, customer analytics. How can I use data to acquire more customers? How can I use data to build customer loyalty? How can I use data to segment my customers? All customers don't behave in the same way. So if I can segment you and say, okay, I have 7 types of customers and you are this type, so I know how you will behave, so I know what to do with you, right? Similarly, I can do things like demand chain and demand creation and supply chain analytics, which is again very important because it reduces my costs. And finally, somewhere here there could be something called pricing analytics. When you look at a marketing mix, how do I price my products to get the maximum benefit or the maximum revenue and profits, right? So just one domain of retail, and look at the way it is segmented. Let's look at quickly look at a few job descriptions. And these are job descriptions of students who studied with us and now are happily in the area of data science, earning more than most of the faculty at Praxis. Okay, that happens all the time. So let's say in the domain of consulting. So we've obviously blanked out the names of the companies. So this is a typical job description, JD, consultant in analytics in our India offices. So this is obviously a multinational. Key responsibilities on this role include excellent analytical and problem solving skills, strong data manipulation, modeling and programming skills in languages like R, SAS and Python, extracting actionable insights. All these things should make a lot of sense to you because you just heard all of this. Okay. This is something that I missed. There is something called visualization where you use products like Tableau, Click and R Shiny and stuff like that. Visualization makes it easier for others to understand what has the data said to us, what is the story that this data has. So it's a mix of heat maps, graphs, charts and stuff like that. Okay. So similarly, let's move to banking and finance. Job title manager risk analytics, because a financial institution faces several types of risks, operational risks and marketing risks and stuff like that, compliance risks. So I want somebody who can understand, look at data and build for me a model that will analyze, understand and manage risk. Okay, so if you look at the second line, work closely with product, credit and tech teams to develop credit models, build and validate, I'm not going into these details, scorecard using logistic regression. So look at this data scientist, he has to work with different teams, understand their business problems and then come back with solutions. Similarly, retail that we talked about, okay, this is again a multinational retail company. Job role is to define, develop and support analytical solutions along with extracting insights from data for improving business decisions of various retail functions, for example, marketing and merchandising. You just saw that in the slides, couple of slides below. And then you work with the analytics team, you analyze data, you support these solutions, manage end-to-end project delivery, etc. Similarly, data science being used in renewable energy. We hire enthusiastic, curious go-getters, position senior data scientists, job location Bangalore, and skill sets, strong learning acumen. Remember we talked about ability to learn, and highly skilled in data interpretation, problem solver. So hypothesis testing, which is part of inferential statistics, insights generation, then testing, training a model, and machine learning techniques. So as I said, every business, every area needs these people. So if you want to get into what we say a career with a future, this is the one. And some of you are hardcore gamers. So this is a company, this is a JD from a very, very popular company, very visible company. Because if you look at even cricket and football, look at the way data science and analytics works there. They start predicting scores, they start predicting match results while the match is still on. And you have these contests running, can I build an algorithmic model to select the best team and get the maximum points out of it? Yeah. So sports analytics is a massive, massive opportunity for people who love sport, love numbers, and want to solve problems. Okay, so a few right at the end, a few comments on programs offered at Praxis, where I work and I teach and I drive this, data science. I have been doing that since 2011. So we give a 2-year full-time PG Diploma in management, but which is ICT. And one of the specializations we offer is data science. And then we have a 9-month full-time program in PGP in data science, which is from our Kolkata and Bangalore campuses. Our AICT approved PG Diploma is only from Kolkata. So you have an option. So if you are a business person who wants to get into the business side of data science, then the 2-year program is good for you. If you are a data and technology person and you have some couple of years of experience and you want to make a contribution in this field, then the 9-month program is the one for you, right? So we were the first full-time graduate program in postgraduate analytics program in India in 2011. We have 500 plus hours of comprehensive course delivery, face to face, in class. So people who join us leave their jobs and come. And we've had a success story of 90% plus placements throughout our 2011 program start. And there are two sides to it. One is there is a huge demand, and the second is we run a very serious and strong Praxis placement program. We've got a lot of recognition in this. We are listed by India Today as one of the top 5 schools to study data analytics. Analytics India magazine, which is the Analytics Vidya, which are the two largest e-magazines on analytics, and I suggest that you go and look at them. You get a lot of information. Both have ranked us 2 among the full-time programs in the country. The top program is the Trinity program offered by IIT Kharagpur, ISI Kolkata, and IIM Calcutta. So we are, after that program offered by 3 top institutes together in India, we are the second ranked program. And in 2016, we also signed an MOU with the government of Andhra Pradesh, and we run their program at the International Institute of Digital Technologies at Tirupati. Yeah. So these are the kind of companies that join us, or that our people join. They join us in our our placement program, and so people from all kinds of services, BFSI, retail, market research, consulting, yeah, and really proud to have them on board. So who should get into data science? I think this is something everybody would want to know. So graduates, postgraduates in engineering, statistics, mathematics, physics, economics with stats and math, commerce with math, MBAs with a tech eco background, good record, no fear of technology, coding exposure helps, but if you don't have it, I mean, at least if you come to Praxis, you don't have an option, we'll teach you. And the most important, passion for problem solving and telling the story. Yeah. And finally, why should you get into data science? This is completely my understanding. One is there is a huge demand for data scientists and analytics professionals. So, and I don't see it going down in the next 10-15 years. There are very high salaries in this today and very accelerated career growth because simply there are not enough people available for this. But the third thing, which is I think the most important, is it's not just about numbers that, lot of demand, lot of money. It is also about doing something exciting because every problem is new, something that requires passion, requires analytical skills, and something that is of prime importance to the health of the business. If your analytics team is weak, there is no way you're going to do well in the business. So, if you are engaged in something that is of critical importance to the organization, you automatically command respect and money. Right? This is what I have to say. Thank you for listening to me. And if you have any questions at this stage, I'll be happy to address them. Yeah. So I have, can you take it on to the right, please? Yeah, this is Tanishk. I like to play with numbers and I have a problem solving attitude, but I don't have much knowledge of Python. It's Python and not Python. Python is something else, but anyway. And don't have any experience in data analyst profile engineer from IIT with operations. How to convince someone about my desire for data analyst course? Oh, so I think all you have to do is only convince yourself. If you want help, I can help because you have the right profile. Remember one thing: there are very few people in the country today with experience in Python and data science. People are just getting there. So if you have an engineering degree from a premier institution, and happy to see a fellow IITian. I'm from IIT Kanpur myself, and if you have you have an operations profile, you understand numbers, I think all you need to do is spend some time training yourself. Give it dedicated time, and once you're done with that, I think companies will pick you up. You don't have to convince anyone. So that was easy to answer. Yeah. Right, Saurabh, data science versus MBA, what to choose and why? I have an answer which people don't like, but that's the only answer. What do you want to do in life? Where do you want to reach? If you know that very well, then I can help you. So first is what MBA is something that you can do at any time in your career. So there is flexibility with an MBA, right? Let's say you are fascinated by data science, and I always say that this is the time to get in because you're still new and there is still a lot of heat in the market. 5 years later or 10 years later, a data scientist will not be as attractive as it is today to the industry, right? MBA is something you can do 2 years later, 3 years later, you can do an executive MBA. So you can do data science, you can do a course in data science, get into a good job, do well there for 2 to 3 years, and then if you feel like getting into an executive MBA program to build your profile, do that. Now let me give you one example here. We have had people joining the corporate world from our data science program from 2012. So we have 2 batches a year. So we have had about 12, 13 batches already. A lot of people wanted to get into data science and then leave it to do an MBA. So far, not a single person has done that because they found this field so fascinating and the growth is so fast. And everybody is greedy, right? So nobody's been able to actually leave this domain and get into an MBA. But people still have an ambition that maybe 5 years from now, I will do a 1 year executive MBA from a top global institute and combine my experience in data science with that to get into some very senior roles. Yeah. So Saurabh, I hope that answers your question. Okay. Dushyant, interesting question. Would you like to move along the ladder from data engineer to data scientist? Well, I think these are two different ladders, really. But I think you can place them very close together. So you can move from one to the other, right? But it's not the same ladder. I think that if you are already in the data engineering domain, you understand data, you probably are exposed to a lot of data and also some data analysis techniques. I think it is possible to shift to data science. You have to come to the business side of things and the context that the data has in the businesses that you are running. So it's possible to do that. It depends on if you want to do it, because data engineering is again something which has a huge demand. But if you feel that data science is more interesting, I think it's possible to do this. Right? Anything else? Yeah. So if you want to know anything more, my email ID is there. You can write to me, and you can go to the Praxis site. I saw some questions on course fee and all. I don't think this is the right forum to answer that. All of that is available on the website at Praxis. So thanks for listening to me, and all the best. Thank you.